radicals, at least for the time being. Right? Square roots, well, they're called square roots because it's a product of two numbers. Squares have two dimensions, right? So the two numbers. If it was a cube root, we'd be looking for three dimensions, right? So three values. Right? So the number under the radical, as you may know or may not, it's review, so it's possible. It's called a radicand. Right? I'll be referring to it as a radicand, but contextually you should be able to pick that up anyway, even if you didn't recognize that as the term. So when we get to number one and I say the radicand is 50, you'll be like, oh, that must be the value under the radical. The number that would be contained in this little cusp here, so right here, that would be the index, but we're not really going to bother with that too much at this point because it's an implied index of 2 giving the square root radical. Right? If it were something other than 2, then you would see a number there. Right? You could also have coefficients. Right? Whatever the number is in front of a radical would be a coefficient or a multiplier of that radical. All right? What we need to focus on here is how to simplify the radicand into a product of a perfect square factor and some other factor, right? Assuming that the radicand itself is not perfect, right? So if you start off with something, let's say you had something obvious like the square root of 36, right? You'd look at that and you say, okay, well, that's not complicated. That's just 6, all right? But if you're not sure, because maybe you have something like the square root of 169. You're like, oh, I don't know about that one. So you pop it into a calculator and take a look real quick, and you see that that's also perfect. All right. What we're going to focus on are the cases that are not perfect. All right. But they have factors that are perfect. All right. So they themselves are not perfect, but they're multipliers, the numbers that make up the radicand, the given radicand. One of them should be perfect, right? And that's what we got to figure out. Right? So in order to do that, we come up with a list of perfect squares. If you happen to know them off the top of your head, that's wonderful. If not, then use technology, right? And I'll show you Desmos and TI. All right. So on the TI calculator, or in the TI calculator, you'd hit y equals, and y1 you would just type in x squared, so x squared, and then go to the table, second graph, and you have a list of perfect square values in y1. The x values are the corresponding square roots, all right? So the perfect squares here, 0, you wouldn't really bother with that, but 1, 4, 9, if you're just looking at the positive cases, I need a marker. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. You could keep going on and on and on. So 11 squared would be 121, 12 squared would be 144, 13 squared is 169. All right, you go down the list. You don't have to know those. You could always just figure it out. I like to have a list up to 15 because those are pretty commonplace. All right, so 196 and 225. All right, and then I skip a few. All right, because you can't be expected to memorize all of them. You use technology if you're looking at some crazy numbers. But like 20 squared, 30 squared, 40 squared, those are easy to remember because just look at it. 20 squared, the 2 gets squared to give you a 4, and you're doubling the amount of zeros that you have. Right? So 20 squared, so I go ... 400. 30 squared would be 900. 40 squared would be 1600. And 2500 for 50 squared. Those are the most popular ones that you would see, in an algebra class on the regions. All right, so when we want to simplify a radical, what we want to do is we want to find a number from this list that divides evenly into the given radicand. All right, so I have a 50 here in number 1. I have that number 50. What I want to do is find a value from this list, the largest possible value that I know will divide evenly into 50. Right? So what I would do is identify where 50 would be in this array of values and start working my way down the list, not up the list, right? So decreasing from that location until I find the number, the first instance that divides evenly into 50, right? But the good news is you could skip right to the halfway point, right? Whatever the number is, whatever the radicand is, the perfect square value that you're looking for will never be larger than half of its value. I take this, I work down the line. This is where 50 would be, roughly. Work down the line to the halfway point, and that's where I start testing, right? So I'd say, does 25 divide evenly into 50? Yes, done. All right. No need to look further because by working down the list, I'm going from largest to smallest. I'm identifying the largest possible value that divides evenly into 50. All right. Or whatever the radicand is. So 25, now I just need to know what the complementary value is. What number would I multiply 25 by to get 50? Same idea as a GCF. Once you identify the GCF, you then divide whatever the expression is by that GCF, right? And when I would explain the GCF, I would always go back to the same example. I'd say, well, what if I asked you to give me two numbers that multiplied to 50? And you're like, oh, I know one of them is 25. What do? You take the 50, you divide it by the 25. You get the result, that's 2, but you don't just throw away the 25, you hang on to that because it's the 25 times the 2 that gives you the 50. It's the pair of values that we need. Once you have the pair of values, one of which is a perfect square, you take the square root of that number, which is 5, and leave the other one alone, and now you have the simplest form. All right, so with number 2, we have 108. So I'd find the number nearest to 108 on my list, and then I'd say, well, I'm not going to really need anything larger than half of 108, so let me drop it down to where half of 108 would be, 54. All right. If I started at the bottom of the list, I might think 4, for example, because 108 divided by 4 is a perfect square, and it divides evenly. But it's not the largest number that divides evenly into 108. All right? That's the problem. You're creating additional work for yourself. You don't want that. All right? So I would start at the highest point and work my way down the list. So I'd say, well, I have no idea. I'll try the 49. Doesn't work. I'll try the 36. It does work. I get the 3. Now that's the best possible pairing that I can possibly have. So possible. So radical 36, radical 3, 6 is the square root of 36. Bring the radical 3 along for the ride, and there you go. All right. So the 20, radical 20. I could find the 20, but if I'm looking for 20, then the next step is going to be to find the half value of 20 on the list. It's like, okay, well, why don't I just jump to the half value of 20? Okay, so I'll do that. Half of 20 is 10. That's where I start my search. Any number below this location would satisfy the requirement of being a factor of 20. Now I just got to find the largest one that is a perfect square that also divides evenly into the 20. All right, so 9's not going to work, but 4 does. Square root of 4 is 2, and you get your radical 5. Now the ones with fractions, you could do them multiple ways, and you know, it's not ideal, you know, in the classroom environment, because people just want one way that works. Good enough for me. I'll just do it that way. 2 ways. Why do we have to do it 2 ways? You don't have to do it 2 ways. I'm going to show you 2 ways. You're going to decide which one you like more. All right. There are some topics where you have to learn how to solve multiple ways. This is not one of them. This is whatever technique you like, go for. All right. So the first method, well, let me talk about theory first. The idea is that you can't divide a radical or an irrational number by a rational number. So I can't just divide the 200 by the 2. Right? One of them's irrational, the other's rational. I can only divide the same kind of number. Right? Because right now they're living in 2 different universes. Right? I need to reconcile that. So either I have to make the radical 200 into something that does not involve a radical, or I have to change the 2 to something that does involve a radical, right? So those are your 2 methods. The way I would change the 2 to something that does involve a radical is by squaring it and then taking the square root, all right? Those 2 opposite operations would cancel each other out, all right? The square root of 2 squared. I mean, you could test it in a calculator. Still 2. It's the same value. All right, but now I've created or introduced a radical. All right, so that makes this radical 200 over radical 4, because 2 squared is 4. Now they're the same kind of number. Now I can divide. 200 divided by 4 is 50 under a radical, which I would then have to simplify. Same problem as number 1. You break it down, 25 and 2, so I'm just kind of breezing through it because we already did it. Square root of 25 is 5, 5 radical 2. All right, so that's one way. The other way is to simplify the 200, the radical 200 first, then divide. All right, so what I would do is I would take this radical 200, I'd go to my list, find the half value of the 200. Oh, actually, I already have a marker. And start working my way down the list from there until I find the first value that divides evenly into the 200. Works out nicely. That first value is 100. So I have radical 100, radical 2. Square root of 100 is 10. And I have my radical 2. We're not done, though, because that's just the numerator. Right? So this becomes over 2, the 10 radical 2. Now I can simplify the 10 and the 2. I still can't do anything with the radical, but I can simplify the 10 by dividing it by the 2. 2 goes into 10 5 times, and there's your 5 radical 2. All right, so roughly the same number of steps, but just different approach. So we'll just do number 5, and then I'll let you do some practice. All right, so same deal, do it one of 2 ways. I'm just gonna duplicate. So I could, bless you. So I can square the bottom and pop a root on it. That makes it radical 300 over the square root of 9. Now I can try to simplify this, right? The one drawback to this approach is that once you square the bottom, if it doesn't divide evenly into the top, you may end up creating more work for yourself, right? So 300 divided by 9, decimal or fractional value. It had simplified to 100 over 3. All right, that's the best you can do at this point, but that's really not that bad, because if we know that this is going to simplify to the square root of 100 over the square root of 3, well, the square root of 100, that's perfect. So that's 10 over the square root of 3. All right. Down the line, I'll review with you how to rationalize denominators. It's a skill. Some people suggest that you can't have a radical in the bottom of a fraction, but that's not true. You can certainly have a radical in the bottom of a fraction. There's nothing wrong with that. All right. So this would be as far as we would go for this approach. All right. If we go the other way, I would take that radical 300. I'd break it down into its factors, right? Multiples of 100 are pretty easy because it's really just, okay, well, one of the factors is going to be 100. And it's just, okay, well, what's the other one? Well, 100 times 3 gives you a 300. All right, so that gives you a 10 radical 3. But it's still over the 3 that was part of the original fraction. All right, so this still has to come along for the ride. We don't just toss that. So 10 radical 3 over 3. All right, so either of these answers would be acceptable. All right, sometimes directions, especially in the Regents, will say without any radicals in the bottom of a fraction, in which case you'd have to rationalize, but we'll cross that bridge down the line. All right. So your assignment is to tackle the remaining problems on pages 21 and 22. So the one problem that's left on page 21 and all the problems on page 22. You don't have to worry about page 23. You don't have to submit either. All right, it's just in class practice.